बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला सय्यिदिना मुहम्मदिन व अला आलि सय्यिदिना मुहम्मदिन व बारिक वसल्लिम। रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Umar Farooq. Today I am going to discuss some very important topics of chemistry: valency of elements and use of valency in writing chemical formula. So be attentive and listen to me carefully. If you concentrate on my words, it is going to be highly beneficial to you. Atoms of elements combine together, forming bonds with each other. And the combining capacity of an element with other elements is called its valency. यानी एक एलिमेंट की दूसरे एलिमेंट के साथ कंबाइन करने की सलाहियत या इस्तिताअत को वैलेंसी कहते हैं. And the valency of an element depends on the number of electrons present in the outermost shell or valence shell of its atoms. Now a question arises: why do atoms form chemical bonds? To find its answer, let's recall the definition of atom again. An atom is the smallest particle of an element that may or may not exist independently and can take part in a chemical reaction. Only the atoms of noble gases exist independently. Note this: the word noble is used for anything which does not combine or react under normal conditions. This implies that it can react under severe conditions. और independently exist करने का मतलब है that they are molecules in the atomic form, that is monoatomic molecules, यानी एक एटम पर मुश्तमिल molecule, and they do not need to combine with other atoms. That's why they are called noble. Whereas atoms of rest of the elements combine with each other, forming bonds to gain stability. It is a universal rule that everything in the world tends to become stable. Atoms achieve stability by attaining electronic configuration of noble gases. Having 2 or 8 electrons in the valence shell is the sign of stability. It means atoms having less than 2 or 8 electrons in their valence shells are unstable. So, attaining 2 electrons in the valence shell is called duplet rule, while attaining 8 electrons in the valence shell is called octet rule. Let's have a look at the electronic configuration of noble gases. Electronic configuration means distribution of electrons in shells or subshells. For the time being, I am going to give you the electronic configuration in shells. These are the atoms of first 3 noble gases, that is helium, neon and argon. And I have written just their atomic numbers with their symbols, which implies that helium has 2 electrons, neon 10 and argon has 18. 2 electrons of helium are present in its first shell, which is also its valence shell. 2 electrons of neon are present in first shell, while in the valence shell we have 1, 2, 3, 4, 5, 6, 7 and 8 electrons. So its electronic configuration is 2, 8. Next we have argon. In argon, the electrons are distributed as 2, 8 and in the valence shell we have again 8 electrons. So 288 is its electronic configuration. Krypton has atomic number 36 and xenon has 54. Let's see their electronic configuration. The first three shells electronic configuration of krypton is 2, 8 and 18, while in the valence shell we have again 8 electrons. In case of xenon, it is 2, 8, 18, 18, and the valence shell contains 8 electrons. And the last noble gas is radon with atomic number 86. Its electronic configuration in first 5 shells is 2, 8, 18, 32, 18, while its valence shell also has 8 electrons. Did you notice something? Noble gases do have 2 or 8 electrons in their valence shells. It means all the noble gases have their valence shells completely filled. Their atoms do not have vacant space in their valence shell to accommodate extra electrons. Therefore, noble gases do not form chemical bonds, and their combining capacity or valency is 0. The importance of the noble gas electronic configuration lies in the fact that all other atoms try their best to have the noble gas electronic configuration. For this purpose, atoms combine with one another, which is called the chemical bonding. In other words, atoms form chemical bonds to achieve stability by acquiring noble gas electronic configuration. An atom can accommodate 2 or 8 electrons in its valence shell in 3 ways. And those are: number 1, by losing valence shell electrons to other atoms if they are equal to or less than 3. Number 2, by gaining electrons from other atoms if valence shell has equal to or greater than 5 electrons. And number 3, by sharing valence electrons with other atoms. So, a chemical bond is defined as a force of attraction between atoms that holds them together in a substance. Depending upon the way how these valence electrons are involved in bonding, following are 2 major types of chemical bonds. And they are ionic bond, which is formed due to complete transfer of electron or electrons from one atom to another. Second is covalent bond, which is formed due to mutual sharing of electrons. When 2 or more atoms of different elements chemically combine through ionic or covalent bonds, the new substance formed is called a compound. And on the basis of bonding, compounds are of 2 types, that is ionic and covalent. Ionic compounds are formed when oppositely charged ions join through strong electrostatic force called ionic bond, whereas covalent compounds are formed when atoms of different elements mutually share their valence electrons. Now it's time to define valency of an element. But valency is defined differently in different types of compounds, because ionic compounds involve transfer of electron, whereas covalent compounds involve sharing of electrons. Let's first define valency of an element in ionic compounds. Valency of an element in ionic compound is defined as number of electrons lost or gained by an atom is called its valency. An atom is a neutral particle overall, as it has equal number of protons and electrons. But if this balance is disturbed, it acquires some charge. Loss of electron creates a positive charge on it, while gain of electron creates a negative charge, and this charged atom is called ion. The charge present on an ion, either positive or negative, is called its valency, which is actually the result of loss of electron or gain of electron. I hope you understand. Let us consider the formation of an ionic compound, sodium chloride. Sodium atom has electronic configuration 281, while chlorine atom has 287. Sodium atom has an extra electron in third shell. On the other side, chlorine is deficient of one electron. So, sodium atom loses its valence electron to the chlorine atom. In this way, sodium atom becomes sodium ion, having electronic configuration of noble gas neon. Whereas chlorine atom becomes chloride ion, having electronic configuration of noble gas argon, 288. The charge created on sodium atom, that is +1, is its valency, and the charge created on chlorine atom, that is -1, is its valency. This whole story is summarized by chemical equations. Sodium atom loses one electron, which is absorbed by chlorine atom. Then sodium ion and chloride ions attract each other by strong electrostatic force, and as a result, sodium chloride is formed, and NaCl is its formula unit. Similarly, magnesium chloride is formed when magnesium atom containing 2 electrons in its valence shell transfers its electrons in valence shells of 2 chlorine atoms. By doing so, magnesium atom forms cation with 2 positive as its valency, and each chlorine atom chloride ion. This is shown by chemical equations. Magnesium atom loses 2 electrons, which are absorbed in 2 chlorine atoms, and they form magnesium chloride. The unit of its formula is MgCl2. So, a positive ion or cation is formed when an atom loses one or more electrons. This is shown by a general equation in which an atom A acquires an positive charge by losing n electrons. For example, hydrogen atom loses one electron to form unipositive ion. Potassium atom loses one electron to form unipositive ion. Similarly, calcium atom loses 2 electrons to form dipositive ion, and aluminium atom loses 3 electrons to form tripositive ion. So the valency of hydrogen is +1, potassium is +1, calcium is +2, and aluminium is +3. Note that in these reactions, electrons are produced along with cations. That's why they are written on the right hand side. Similarly, a negative ion or anion is formed when an atom gains one or more electrons. This is shown by this general equation in which an atom B acquires a negative charge by gaining n electrons. For example, hydrogen atom absorbs one electron to form hydride ion. Bromine atom absorbs one electron to form bromide ion. Similarly, oxygen atom gains 2 electrons to form oxide ion, whereas nitrogen atom gains 3 electrons to form nitride ion. So valency of hydrogen in hydride ion is -1. Valency of bromine is -1. Valency of oxygen in oxide ion is -2. And nitride has a valency of -3. Note that in these reactions, electrons are absorbed by neutral atoms. That's why they are written on left hand side. One more thing to be noted is that positive ions are also called positive radicals and negative ions the negative radicals. Now we're going to define valency of an element in covalent compounds. So valency of an element in a covalent compound can be defined in 3 different ways. First is, number of electrons shared by an atom is called its valency. Second is, number of covalent bonds formed by an atom is called its valency. Or, number of hydrogen atoms which combine with an atom is called its valency. Look at the structures of some covalent compounds like hydrogen chloride, water, ammonia, and methane. The yellow solid lines represent covalent bonds. So, according to the definition of valency, we conclude that the valency of chlorine, oxygen, nitrogen, and carbon is 1, 2, 3, and 4 respectively, because chlorine forms one covalent bond, oxygen forms two covalent bonds, nitrogen forms three, and carbon forms four covalent bonds. Now look at the structure of sulfuric acid. Can you find the valency of sulfur? Yes, of course, it is 6, as it forms 6 covalent bonds. And each oxygen has a valency of 2, because each oxygen atom forms 2 covalent bonds. On the next slide, I am going to give you a valency chart in which valencies of some common elements and radicals are given. I expect that you will learn this chart by heart, or at least draw this chart on your notebook and compare it with that given in your textbook. I have drawn 7 columns in this table. First and fourth columns are for the elements or radicals. Second, fifth, and sixth columns are for their valencies. In fifth column, valencies in covalent compounds, while in sixth column, valencies in ionic compounds will be given. Third and seventh columns are for their ionic formulae. We start with sodium, potassium, and silver. Each has a valency of +1, and these are their formulae. Magnesium, calcium, barium, and zinc all have +2 valency, and these are their formulae. Copper, mercury, and iron show variable valencies. Copper has valencies +1 and +2, and these are called cuprous and cupric ions respectively. Mercury also has valencies +1 and +2, and these ions are called mercurous and mercuric respectively. Now iron shows valencies +2 and +3. So Fe2 positive is called ferrous ion, and Fe3 positive the ferric ion. So you notice that in case of lower valency, the element's name ends at us, OUS, while in case of higher valency, its name ends at ic. Next we have aluminium and chromium. Both show a valency of +3. Now all these cations are metal cations, but there are some cations which consist of group of atoms of non-metals such as ammonium and hydronium. Each has a valency of +1, and their formulae are NH4 positive and H3O positive respectively. Now focus on the column number 4. As you know that non-metals form both ionic and covalent compounds. That's why I have made separate columns to show their valencies in either case. For example, hydrogen. In covalent compounds, its valency is 1. Not positive, not negative, just 1, which means that it forms only one covalent bond. It also forms H1 positive and H1 negative ions. H positive is called hydrogen ion, while H negative is hydride ion. Similarly, chlorine, bromine, and iodine have valency of 1 in covalent compounds, meaning that they form only one covalent bond, while their valency is -1 in case of ionic compounds, and they are called chloride, bromide, and iodide respectively. Oxygen forms 2 covalent bonds, whereas sulfur shows variable valencies, that is, it can form 2, 4, or 6 covalent bonds with other atoms. In ionic compounds, both show valency of -2. and are called oxide and sulfide ions respectively. Next is nitrogen and phosphorus. In covalent compounds, nitrogen forms 3 covalent bonds, whereas phosphorus can form 3 or 5 covalent bonds. In ionic compounds, both have valency of -3, and these ions are called nitride and phosphide ions respectively. Now, boron and carbon both form covalent compounds only, with 3 and 4 as their valencies. Arsenic forms 3 or 5 covalent bonds, but it has valency of +3 in ionic compounds, and the formula of its cation is As3 positive. Now look at these radicals. These are anions consisting of group of atoms in which hydroxide, cyanide, bicarbonate, bisulfate, nitrite and nitrate show a valency of -1, while carbonate, sulfite, sulfate and thiosulfate show a valency of -2. And phosphate ion has a valency of -3. In covalent compounds, their valencies are just the numbers without the negative charge, which indicates that they form this number of covalent bonds, which is shown in green color. Now students, in chapter number 7 of your book, you will come across a term oxidation number, which is the apparent charge present on an atom. That may be a single atom or a part of a group of atoms. But right now, we use the term valency for this charge. One thing to be noted that when you write the valency in the superscript of an ion, the number is written first and charge afterwards. I hope you understand. Here is a snapshot of the valency table given in your textbook. Unfortunately, the author has presented it in generalized form and no detail is given. Now, moving on to our next topic of today's lecture, that is use of valency in writing chemical formula. In your textbook, this is given under the heading of how to write chemical formula. Since the author has described the method of writing chemical formula of ionic compounds only, so it should have been like this: how to write chemical formula of an ionic compound, and to be more precise, how to write empirical formula of an ionic compound. As you know that ionic compounds are represented by empirical formulae. While writing empirical formula of an ionic compound, first we write the formulae of both cation and anion, cation on left while anion on the right, and finally write the valency of cation in the subscript of anion and vice versa. That is, valency of anion in the subscript of cation without the charge positive or negative. Just write the numbers. This is how we write the empirical formula of an ionic compound. Note that if X is equal to Y, then they cancel out each other, and we do not write valencies in the subscript. One more thing is that if an ion consists of a group of atoms and you have to write valency of the other ion in its subscript, then use parentheses. The following examples will help you understanding these points. For example, calcium carbonate. The formula of calcium ion is Ca2 positive and that of carbonate ion is CO3 2 negative. Their valencies are same and cancel out each other, so we are left with CaCO3. Likewise, magnesium carbonate, magnesium ion is Mg2 positive, this is carbonate, valencies are cancelled out and we are left with MgCO3. In case of calcium bicarbonate, the valencies are not cancelled and we write the valencies of each ion in the subscript of the other. While writing 2 with HCO3, we use parentheses and is read as CaHCO3 whole twice, that is calcium bicarbonate. Next we have magnesium bicarbonate, magnesium ion, bicarbonate ion, and the formula is just like calcium bicarbonate. So MgHCO3 whole twice is the formula of magnesium bicarbonate. Next is calcium chloride. Calcium ion is Ca2 positive, chloride ion Cl negative. So we cross their valencies and its formula is CaCl2. Likewise, magnesium chloride, Mg2 positive, Cl negative, MgCl2 is its formula. Calcium sulfate. Now calcium ion is Ca2 positive and sulfate is SO4 2 negative. So again we have same valencies which cancel out each other and we are left with CaSO4, which is the empirical formula of calcium sulfate. Magnesium sulfate, MgSO4, because 2 positive is cancelled out with 2 negative. I hope you understand. Next is calcium hydroxide. Calcium is Ca2 positive, hydroxide ion has a formula OH1 negative. So again we use parentheses with OH because it is a group of 2 atoms. So CaOH whole twice is the empirical formula of calcium hydroxide. Magnesium hydroxide has same formula just like calcium hydroxide, that is MgOH whole twice. Now calcium nitrate, Ca2 positive is calcium ion and nitrate ion has a formula of NO3 1 negative. So we use parentheses with nitrate. Similarly, magnesium nitrate is similar to calcium nitrate, MgNO3 whole twice. Next we have calcium oxide, Ca2 positive, O2 negative, 2 is cancelled out with 2. So we are left with CaO, and magnesium oxide is similar to calcium oxide, MgO. The formula of calcium phosphate. Calcium ion is Ca2 positive, phosphate ion is PO4 3 negative. Now 2 and 3 are crossed. The valencies are crossed with each other. So the formula of calcium phosphate is Ca3 PO4 whole twice, and magnesium phosphate is Mg3 PO4 whole twice. Next we have sodium carbonate. Now sodium is Na positive or Na1 positive. Carbonate is CO3 2 negative. So we cross their valencies and write 2 with sodium. The formula is Na2CO3. CO3 is ones. So we do not use any bracket. Similarly, ammonium carbonate. Now ammonium ion is a group of atoms. So when it combines with carbonate ion, it is twice NH4 twice CO3, because ammonium ion is a group of atoms. Now sodium bicarbonate, sodium and bicarbonate ion have same valencies, so we write as such NaHCO3. Ammonium bicarbonate, both have same valencies, one positive and one negative, So we are left with NH4 HCO3, ammonium bicarbonate. Next we have sodium chloride, Na positive, Cl negative. So NaCl is its empirical formula. Ammonium chloride, NH4 positive, Cl negative. NH4Cl is its empirical formula. Sodium sulfate, Na positive, SO4 2 negative. So we write 2 in the subscript of Na. So its formula is Na2SO4. And while writing the formula of ammonium sulfate, we use parentheses with ammonium, NH4 whole twice, SO4, that is ammonium sulfate. Next we have sodium hydroxide, Na positive, OH negative. So NaOH is its formula. And ammonium hydroxide, NH4 positive, OH negative. NH4OH is the empirical formula of ammonium hydroxide. Next is sodium nitrate, Na positive, NO3 negative. So NaNO3 is the empirical formula of sodium nitrate. And ammonium nitrate is likewise NH4NO3. Next is sodium oxide, Na positive, O2 negative. Oxide ion is O2 negative. So we write 2 in the subscript of Na, and the formula is Na2O. Similarly, ammonium oxide, now we use parenthesis with ammonium ion, NH4 twice O is the empirical formula of ammonium oxide. And then we have sodium phosphate, Na positive, PO4 3 negative. So its empirical formula is Na3PO4. And writing the ammonium phosphate formula, we use parentheses with NH4. So its formula is NH4 thrice PO4. Next we have ferrous carbonate. Fe2 positive is ferrous ion, carbonate is CO3 2 negative. So 2 positive cancels out with 2 negative, and we are left with just FeCO3. And ferric carbonate is Fe3 positive, CO3 2 negative. So their valencies are crossed, and the formula of ferric carbonate is Fe2CO3 thrice. Next we have ferrous bicarbonate, Fe2 positive, HCO3 1 negative. So we write 2 in the subscript of HCO3 using parentheses, FeHCO3 whole twice. Now ferric bicarbonate is Fe3 positive, HCO3 1 negative. So its formula is FeHCO3 thrice. I hope you understand. Some more examples. Ferrous chloride, Fe2 positive is ferrous, Cl negative is chloride, so its formula is FeCl2. Ferric chloride, Fe3 positive is ferric, Cl negative is chloride, so FeCl3 is its formula. Next we have ferrous sulfate. Now ferrous and sulfate both have same valencies, 2 positive is cancelled out with 2 negative. So the formula of ferrous sulfate is FeSO4. But ferric sulfate has a formula Fe2SO4 whole thrice. Next is ferrous hydroxide. Ferrous ion is Fe2 positive and hydroxide ion is OH1 negative. So its formula is FeOH whole twice, and ferric hydroxide is FeOH whole thrice. Ferrous nitrate, Fe2 positive, NO3 1 negative. So its formula is FeNO3 whole twice. And the formula of ferric nitrate is FeNO3 whole thrice. Next is ferrous oxide. Ferrous is Fe2 positive and the formula is oxide ion is O2 negative. Their valencies are cancelled out and the formula is FeO. Ferric oxide, Fe3 positive ferric, oxide is O2 negative. Valencies are crossed and the formula is Fe2O3. Ferrous phosphate. Ferrous ion is Fe2 positive, phosphate is PO4 3 negative. Now we cross their valencies and write 3 in the subscript of Fe, and PO4 becomes twice. Ferric phosphate. Now Fe3 positive is ferric and phosphate has a valency of 3 negative, which are same, so they cancel out each other, and the formula is FePO4. I hope you understand. If you have any questions, please do write in the comments below. Thank you.